my name is Edwin Chung, and the title of my project is Sustainable Style. The purpose of my experiment is to find a novel, efficient, effective, and safe method to recycle cotton. Our world has been taken over by fast fashion, and as a result, more clothing has been gone to waste. This is because of the low cost and high efficiency of manufacturing for fast fashion products. This has caused consumers to have a less worthy incentive to keep their clothing and reuse them instead of throwing them away. In my project, I used a method called coagulation, and in my hypothesis, I stated that if cotton was coagulated in multiple liquids such as lemon juice, white vinegar, and water, then lemon juice would have the best coagulation because of its high acidity. Before I move into my procedure and materials, there is some necessary information that needs to be gone over. First of all, what is cotton? Well, cotton is made out of cellulose, and cellulose chains are like this, long strands of hydrogen, oxygen, and carbons. As you can see here, this red oxygen and these two carbons are connected through what is called a glycosidic bond. And to specify more, this whole chain is one unit of cellulose, which can be connected to more units of cellulose through hydrogen bonds. In my experiment, we were trying to target hydrogen bonds to disconnect these units of cellulose so that they can be reconnected to different cellulose due to the process of recycling. In my materials, the most important ones that are used in my experiments are isopropyl alcohol, testing tubes and flasks, a heat-safe flask, Japanese organic cotton, sodium hydroxide in the form of Drano, a heat pad that is controlled, mason jars, distilled water, white vinegar, lemon juice, goggles, and nitrile gloves. In my procedure, I first made sure to sanitize every material I was using with isopropyl alcohol. This is to ensure the controlling of my experiment and the safety for myself. I used Drano to dissolve the cotton so that it can be coagulated, and in the form of Drano, I used 177 milliliters of sodium hydroxide to 60 milliliters of water as a ratio of my solvent. Then I dissolved the cotton textile in the form of 0.4 grams for the total time of 2 hours and 30 minutes to check on any results. Then I prepared a coagulation liquid inside of an airtight mason jar, and I used 3 coagulation liquids, water, lemon juice, and white vinegar. After the cotton was dissolved, I placed the dissolved cotton inside the coagulation liquids. I then let each cotton coagulation set for 25 hours, and in the result, 24 hours. And as a result, cotton was left in the coagulation mason jar, and then I filtered it out to get the leftover cotton that was coagulated. Then, after collecting the fibers, I dried them out and used the weight to find how much cotton was recycled. In our data, we were able to find that my hypothesis was incorrect. Instead, water was the best coagulation liquid out of all the 3 samples, and this is because of the process of dilution. Just comparing these 2 acidic liquids, you can see the difference in the forms of cotton that was recycled. For white vinegar, the cotton was a little bit bigger and had less clumps than white vinegar, and this is because of the acidity content. There are 2 forms of acidity, citric acid and acetic acid. White vinegar has acetic acid, and citric acid is lemon juice. And as a result, the higher content of acidity also breaks glycosidic bonds, which can form less structured cotton that can be easily broken. And so that's And as a result, this is why water would be the best form of coagulation liquid, because instead of breaking down glycosidic bonds, it dilutes them. And what we want is to only break the hydrogen bonds. And water does a good job of not breaking any glycosidic bonds, so that the NaOH or sodium hydroxide doesn't further break down the cotton. In these graphs, these also emulate the results with distilled water having a sample average of 0.37 grams, white vinegar having an average sample weight of 0.2 grams, and lemon juice having an average sample weight of 0.27 grams. This graph right here shows a perspective of how much cotton was between each sample average. And in my discussion, I was able to find an interesting hypothesis from another famous scientist in the process of cotton recycling. This hypothesis stated that acidity caused the breakage of glycosidic bonds. And as a result of my experiment, I can confirm this, or at least hold some evidence to find that acidity does break down the glycosidic bonds as well as the hydrogen bonds. This is crucial in chemically recycling cotton, because it can show that hydrogen bonds are being connected together and reforming cotton into larger samples and larger sizes compared to breaking down cotton, which makes the durability weaker. And as a conclusion, I found that water was indeed the best coagulation liquid, not only because it diluted the glycosidic bonds instead of breaking them, but it also is recyclable. So if the water is evaporated, then the NaOH can be reused, as well as the other materials, due to some sanitation processes. And as my application, I would like to see, if I were to complete this experiment again, I would look forward to using enzymes, in addition with sodium hydroxide, to make the process more efficient. This whole process took a span of around 2 days. And as a result of the coagulation and dissolving the cotton, it took more time than expected. To quicken this process, enzymes would be not only more cost efficient than using heat, but it would also help the cotton become more, break hydrogen bonds easier, and which could result in faster efficiency. And as a result of fast fashion, I would like to go into more other materials besides cotton, such as polyester and other plastics used in products for clothing. If we could find this out, then clothing could be fully recyclable, no matter the type of material or how damaged it is. Thank you for listening to my project, and I look forward to your judging sessions.